This is Electric Universe, and today I'm going to share an article posted to the archive of pwg.gsfc.nasa.gov titled Electric Currents from Space. When a bright aurora is seen in the auroral zone, a strong magnetic disturbance is usually also observed there. The disturbing magnetic field can be much stronger than that of a magnetic storm, but it is strictly local, fading away quickly as one moves equatorward. This limited extent suggested that the currents which disturbed the field flowed somewhere nearby, probably near the auroral arcs. The Norwegian Kristian Birkeland, who carefully observed auroral disturbances around the turn of the century, concluded that those currents flowed parallel to the ground, along the auroral formation. Any electric current, however, must flow in a closed circuit, and since it seemed to be caused, like that of the aurora, by processes taking place in distant space, Birkeland proposed that it came down from space at one end of the arc and returned to space at the other end. The drawing here illustrates the idea and was taken from Birkeland's 1903 report on his expeditions to the auroral zone. Dynamos. How can electric currents be generated in space, or for that matter, on the Sun and in the Earth's core? When a bright aurora is seen in the auroral zone, a strong magnetic disturbance is usually also observed there. The disturbing magnetic field can be much stronger than that of a magnetic storm, but it is strictly local, fading away quickly as one moves equatorward. In all those cases, some electrically conducting fluid appears to be moving through a magnetic field plasma in space and on the Sun, molten iron, probably, in the Earth's core. It can then be shown from the principles of physics that if a closed electric circuit exists, parts of which are moving through a magnetic field while other parts are not, an electric current will arise. Additional conditions must also be satisfied. The electric energy needed to drive the current is taken from the motion, which is slowed down. Long ago, a machine that generated electricity was named dynamo. Today's preferred term is generator. In analogy, a setup where a conducting fluid flows through a magnetic field and creates an electric current in the above fashion is called a fluid dynamo, or when a fluid process is clearly implied, simply dynamo. Faraday understood this very well. Knowing that water conducted electricity because of dissolved salts, he tried in 1831 to observe such a dynamo experimentally. He strung a wire along Waterloo Bridge in London and dipped its ends into the river at two separated points so that its circuit could be completed through the flowing water. He then tried to measure the electric current generated by the river's flow through the magnetic field. The idea was sound, but the current was too weak to be measured by him. Faraday nevertheless speculated that the aurora, which he believed to be an electric phenomenon, might be powered in a similar way by the Gulf Stream flowing to the northeast through the Atlantic Ocean, beginning just offshore from the U.S. Of course, what Faraday forgot here was that to connect the ocean to the aurora, the current would have to cross the lower atmosphere, which is an excellent insulator and would block its flow. An interesting dynamo of this type exists between the planet Jupiter and its innermost big moon Io. The space shuttle can also generate electric power that way, at the expense of its orbital energy, using a long wire dangling from it into space. Such a space tether experiment was conducted aboard the Space Shuttle Columbia on the 25th of February, 1996, ending unexpectedly when the tether suddenly broke. Sir Joseph Larmor in England first proposed in 1919 that dynamos consisting entirely of fluids might explain the creation of sunspot magnetic fields. His idea was that as solar plasma flowed through magnetic fields, dynamo effects produced the very same currents which also created those magnetic fields. Because this is a process which lifts itself by its own bootstraps, the magnetic fields needed by the dynamo are produced by the electric currents which are its output. It must build up gradually, starting from seed magnetic field of a different source. Such a dynamo mechanism was also believed to be the source of the magnetic field arising inside the Earth's molten core. It is impossible to observe that region directly, but in 1964, Stanislaw Brzezinski in Russia mathematically demonstrated a possible class of such dynamos. The slow decade-by-decade variation of the Earth's field probably comes from slow changes in the flow patterns of the core, not, as Haley once proposed, from magnetized spherical layers, one inside the other, all rotating differently. Birkeland Currents. If the Earth has an open magnetosphere with field lines linked to the solar wind, it too produces a fluid dynamo of sorts. In a plasma, electricity flows easily along magnetic field lines, making them behave like copper wires. Open field lines from the solar wind that dip into the polar ionosphere can then act like the wires which Faraday dipped into the Thames River, and they can draw an electric current, slightly slowing down the solar wind in the process. If the bundle of open lines maps to the region inside the auroral oval, it can be shown that the dynamo currents from the above process flow earthward on the morning side of the magnetic pole and spaceward on the evening side. One might guess that the circuit would be completed by connecting the two flows across the polar ionosphere, from the morning side to the evening side. The situation is more complicated, however, because the flow also deforms the field lines. When in 1973, the Navy satellite Triad flew through this region in a low-altitude orbit, its magnetometer indeed detected the signatures of two large sheets of electric current, one coming down on the morning side of the auroral zone, one going up on the evening side, as expected. Because Kristian Birkeland had proposed long before currents, which linked Earth and space in this fashion, they were named Birkeland Currents, by Shield, Dessler, and Freeman in a 1969 article predicting some of the features observed by Triad. Typically, each sheet carries 1,000,000 amperes or more. But that wasn't all. Equatorward of each current sheet, Triad noted a parallel sheet almost as intense, flowing in the opposite direction. Those field lines were no longer open, but closed inside the magnetosphere. It thus seemed that most of the electric current coming down from space, about 80%, did not choose to close through the ionosphere across the magnetic poles. Rather, it found an alternate way. It flowed in the ionosphere a few hundred miles equatorward and then headed out again to space, where the currents, presumably, found an easier path. A 1976 study by Takeshi Iijima and Tom Paterma used Triad data to map the average footprints of these sheets in the polar ionosphere, including their intricate overlap at midnight. Their result is plotted here. The map is centered at the northern magnetic pole, though southern data were combined to produce this graph. Midnight is at the bottom, and noon, where some minor additional currents exist, is at the top. Dark shadowing indicates currents flowing towards Earth. Light shading, currents flowing outward into space.